All right, problem 539. If 2 to the power of x plus 4 equals 2 to the power of 3x minus 1, what is the value of x? So if we start out thinking about it here, each of these expressions has the same base. So if we think about the number 2, if I have the same base here, I probably need the same exponent for them to be equal, right? So if I say like 2 to the first, then this one has to be 2 to the first. If this one was 2 to the fourth power, then this one would also have to be 2 to the fourth power in order for these to remain equal. Well, just because we have variables and things up here doesn't change anything. You know, when you have the same base and you have an equation that's saying these are equal, that means that our exponents also have to give us equal values. So let's take this here. We have 2 to the power of x plus 4, and we say that equals 2 to the power of 3x minus 1. Well, in order for both of these to be truly equal, we have to think about these exponents. The bases are the same. The base is 2 for each of these, which means then that our exponents have to be the same. So let's figure out what value of x is going to give us this same value for our exponents. So the equation we'll use is simply x plus 4 has to equal 3x minus 1. And that's a pretty simple equation to solve. Let's subtract our x from each side. And let's go ahead and just add 1 while we're at it. So right now we've got 5 is going to equal 2x, which means that 5 halves has to be the value of x, or you could say, you know, that's the same thing as 2.5 if you're more comfortable with that. So in order for this to be a true statement here, the value of x has to be 2.5, which means that we'd have 2 to the power of 2.5 plus 4 should equal 2 to the power of 3 times 2.5 minus 1. 2.5 plus 4 is 6.5, so we're saying 2 to the power of 6.5. 3 times 2.5 should be 7.5, minus 1 would be 6.5. So we get 2 to the power of 6.5, which we know that those would end up being equal. So our answer here, we're going to say x is going to equal 2.5, or 5 halves is perfectly acceptable. This is how to do it algebraically on paper. Let's do it on the calculator real quick. So I got my calculator out here, and I'm going to solve this as a system of equations. Solve this equation by taking each one and making it into its own function. So if we say y is equal to 2 to the power of x plus 4, and then my second function here will be y equals 2 to the power of 3x minus 1. Let's plug them into the calculator here. So I'm going to say 2 to the power of x plus 4. And the second one, 2 to the power of 3x minus 1. Now if we graph these, there's our first exponential function. And here comes our second one here. So this one takes a little longer here, right, to begin rising up. This one is going to be a little steeper than this one, which means they're probably going to intersect somewhere up here. And since I've already done the problem, I know how far up I need to look. So I'm going to adjust my window here so that you can see it. I'm actually going to make my Y max quite a bit higher. I'm going to say about 100 here so that you can see where they're going to intersect. So it's going up here And then our second function comes through here. Goes up, and you see they cross right up here. So if we do our intersect function, let's do second trace, number 5. Let's mark those functions. So we're on the red one here, enter. On the blue one, enter, and then let's hit enter one more time. And you see it says the intersection is at 2.5, which is what the x value needed to be, right? X equals 2.5. And then the fact that this 90.509668, wonder what that is. Well, I bet if we took 2 to the power 6.5, it should be somewhere around there. Let's double check and see. 2 to the power of 6.5. And you see that's where we get our 90.50966, so on there. All right, so just wanted to make sure you have the opportunity to learn how to use that calculator a little bit more. This is problem 5-39. This is Mr. Boyd. Hope that this video has helped you out. Once again, our answer, x equals 2.5. Good luck.